basically, I'm going to start by kind of giving you an intro to kind of the concepts behind a data model and what it is, and then we'll talk specifically about the data model we've been developing, and then we'll see how the data model is represented or stored in the Geo Database. So the central concept that I like to talk about with data models is this idea of enterprise GIS, which is basically that you can use GIS to manage all kinds of different aspects of your organization. So for gardens, we have lots of different things, lots of different functions that we're trying to perform to keep the place running. So you could use GIS to basically do all sorts of stuff. So you could use it to plan for emergency response, so plan evacuation routes, things like that. You can use it to manage projects that you have. Maybe you're doing a construction project in an area of your garden. You can have the construction documents visualized in your GIS, information attached to it. You can use it for customer service kind of things, so visitor applications. You want to make visitor maps, guided tour or self-guided tour maps, things like that. You can use GIS for that. Any engineering stuff, if you need to be able to provide information to your construction company on, where your trees are and what maybe the contours of the land are, things like that, you can store all that into your GIS. Mobile stuff is one of the greatest things I think that's really getting popular with GIS is take your GIS out on a mobile device, take it out on your cell phone or a PDA or something like that, or a GPS unit, and go out in the field and record information about your plants or make changes to your maps. Code compliance is another thing. Logistics, UPS likes logistics. There's work order management, which is really cool. So picture being able to go out in the field with you have your mobile device with you, you come around and a tree came down in a storm. You can note the location of that tree, and maybe even if you have it set up, you can get a work order going so that if you have a larger garden, and the work order can go into a system where the grounds crew can know where that tree is and that they need to go out there, and all that stuff can be automated within the GIS. I like the idea of using it for site selection. So if you're going to put in a new desert garden and you want to be able to find the conditions that are correct, it's got to have full sun, it's got to have well-drained soil, and whatever other characteristics you might have, you can use the GIS to be able to determine the best location for that garden. For day-to-day operations, it's great for that. If you have a large enough traffic or you have a large enough garden, you have traffic issues, you have an event, you need to figure out where to park people, GIS is great for that. And then I think probably the most common use is for asset management, to really just know what you have and know information about that and store that information in the GIS. So that's really the concept of enterprise GIS, is that you can use it for just about anything. So this is really the foundation of what we designed the data model on, is that we wanted to be able to create a system that people could do all these different things in it. And it doesn't mean that you have to. It just means that if you want to, the capacity is there to do it. So what is a data model is always a good question. This little quote up here is really the technical definition of it, but I like to think of a data model really more as a database schema or a template for starting a project. So by database schema, I mean that it defines the rows and columns that are in your database and the relationships between those things. But really, it is a template. It's something that you can just download and start putting stuff into without having to do any of the design work yourself. And there's currently over 30 different data models out there for ArcGIS, depending on what industry you're in. So there is one for the petroleum business. There's one for foresters. There's one for doing hydrological analysis. There is one for biodiversity conservation. There's all these different things, depending on what industry you're in and what you're using GIS for. There's all these different templates out there to help you get started. So the goals of our project to create a data model was basically to make it free. First of all, we know that gardens are usually pressed for money, so we wanted to make it something that was free. You don't have to pay any yearly maintenance costs on it or anything like that. And basically we wanted to make it a template for starting your project. And we wanted to make it this idea of being modular is that it comes in light, medium, or extra strength varieties. But basically is you just take the pieces that you want to use out of the model and and use those as you see fit. And if there's things that you don't need, don't use them, and you can actually just delete them right out of the model. And we wanted to make sure that it was focused on providing the features that provided the greatest benefit. So we wanted to make sure that, all the things that are done really commonly in gardens, we definitely had in there. And some of the things that are maybe used a little bit less often are not in there. And then we wanted to make it work with existing plant record systems. We realized that most gardens already have some way that's hopefully electronic that they're keeping their plant records, keeping track of their accessions, things like that. And we didn't want to create a system that would be a replacement. We wanted to make something that worked really with those plant record systems. So you'll see later that, we store very basic information about plants in the GIS, and it's basically just the information that we need to be able to make our collection maps. And that the general idea is that you want to be able to link the GIS to your plant record system if it's in BGBase or FileMaker or whatever you may have your plant records in. We wanted to make a way for those things to communicate with each other. So as I mentioned before, creating this data model is kind of like modeling an entire city, that we have all the complexities that a city might have inside the model or inside of our gardens. So there's lots of different things, and we knew that we couldn't make everything. We didn't have the time or money to be able to design all these things, so we focused on things that were most important to everybody. So we did a survey at the beginning of the project to figure out, what did people value the most? What do they really want out of their GIS? And of course, plants came up first as the first most important piece. And then base map being all the stuff that's kind of that background data that I was talking about, your sidewalks and maybe your planting beds and things like that. And then facilities and infrastructure came up as the next one. And that's, would be your utilities and your buildings and any other facilities you might have on your property. So that's what we really worked on when we built this, is that we created the base map part first, we did the facilities part, and then we made a very basic plant piece that was meant to connect to the plant record system, like I mentioned. And the complexity of the model, there's currently over 150 different things in the model. We call those things objects, and those might be different things that you're going to model on your property. So maybe they are your benches, your fences, things like that. So that each one of those would be an object. So there's 150 different types of things in there so far. So we talk a little bit about the Geo Database and how data models connect to the Geo Database. So the Geo Database is essentially where all your GIS data is stored. And there's different ways that you can store GIS data in ArcGIS, but the Geo Database is by far the best way to do it. It allows you to have the most control over the way things are done. And there's a number of different elements that are part of the Geo Database that you guys should know the terminology about. And I'll point out these things in the data model, so you'll get a chance to see these things firsthand. So the most common thing inside a Geo Database is what we call a feature class. And that's essentially for vector data, which would be points, lines, or polygons. So there would be, if you have a bunch of point data for your plants, that would be a point feature class. If you have some line data for some roads, that's a line feature class. If you have polygon data for your planting beds, it's a polygon feature class. And then there's another type, which is annotation, which is basically labels. So if you wanted to have labels on your maps for the scientific name and accession number of a particular plant, you would use annotation to store that information. And then there's just standalone tables. Now, feature classes are generally some kind of shape, like a point, line, or polygon, plus the table behind it that has the data about it that maybe says how big your plant is, what the scientific name is, etc. A table would just be a bunch of data that came from a regular database that doesn't have any features associated with it. So maybe it's a list of contact information or a list of provenance information for your plants. That could just be in a standalone table. And then there's relationship classes that connect things together. So maybe you want to know that a particular section, you have a section line drawn for a collection of plants. Inside that collection of plants, you want to know what plants you actually have. So you could have a relationship between those things so that when you click on the collection boundary, that you can get information about all the plants that are inside of it. And then there's something called a topology, which is, we have this in the data model, and it's basically a set of rules that kind of define the geometry for your garden. So you can have rules like structures or buildings can't be over water. You can't have sidewalks overlap grass areas. And this basically makes it so that when you're drawing your data or digitizing it, it kind of creates rules for quality. So the ArcGIS is set up so that it can show you where you've made these errors so you can correct them really easily. And we'll look at that a little bit later today. There's a thing called a featured data set, which you can kind of think of as a folder that holds feature classes that have some similarities. So if, say, two feature classes like sidewalks and planting areas, they have a topology rule that says they can't overlap, those would want to be in the same feature data set. And I'll show you that later. There's a thing called a subtype, which is pretty important. And you can have a feature class. Say you have a feature class for planting areas. These are different areas that you may have plants growing. And you could have planting areas that maybe they could be a turf planting area, which has just got grass on it. It could be a wild or unmanaged area, which is just kind of like maybe a meadow or something like that. Or you could have just a straight up soil planting area where you manage that and maybe mulch that. And we'll talk about those a bit later as well. And then there's domains, which is basically a list of kind of valid values you can have for any field. So this is stuff that kind of controls the quality of your data. So for maybe you have a field that says that keeps track of all the people who collect the data. So you have maybe a few data collectors, the people that are out in the field with a GPS unit or something, and they're collecting data, and you want to track the names of the person who did that. You can have a list of all those names so that instead of typing the name in 5 different times and spelling it differently and capitalizing it differently, they just select it from a list so that you get the same value in that field every time. So we'll see how those work in action a little bit later too. So this is a really rough diagram of what the data model is kind of like, and I don't expect you to be able to read this, but this is basically showing the complexity of the data model. But we've done all this design work already so that you don't have to think about this stuff and you can just start putting data in there. So quickly, I'll make that go away. So I wanted to show you a little bit about how the Geo Database actually works. So in this diagram here, we're gonna look at how these things are connected. So basically, the things in blue are feature classes, and then the things in green are basically relationships between those. You guys probably in the back probably can't read the text on here, huh? Yeah, this is a little bit tough on this projector. The basic idea here that I want to show you is that so this example here is that a section or a collection of plants or an area of your garden has a relationship with a structure, so that when you click on the section, you navigate this relationship and you can find all the structures or buildings that are inside of it. And buildings or structures have a relationship with enclosures. So if you're at a zoo, maybe you have a building that houses all of your reptile species. So we can click on that building now and we can find information about the animals that are inside of it. We can also click on that building and we have a relationship with entrances and exits. So you may have all of the entrances and exits of that building mapped, which could be really useful for emergency management kind of stuff. So you can click on that building and instantly find out the information about the entrances and exits. And you may want to know who's got the key to that, who should I call if I can't get in, things like that. So again, this structures has a relationship here with point of contact. So you can have contact information stored for that. Who is the emergency contact? Who's the facility manager? Things like that. And that's the basic relationship that I wanted to show you that we've put together in the Geo Database so that you don't have to think about this stuff, and a lot of these things are already built in. We zoom into this structures feature class here. We zoom into it and we look at it in a little bit more detail. We'll find out that all these different fields, we can track information about the structure. And again, you don't have to be able to read all this, but we're tracking information. We have information about the name of the structure, the address of it, when it was built. You can have a link to any documents related to that. If you have the blueprints for that building, you can link it up to that. How many levels does it have? Does it have water service? Does it have gas service? Does it have telephone service? Does it have sewer service? Does it have a heating system, cooling system? All that stuff. We can track information about it. Or you can choose not to track that stuff. If you don't want to fill in those blanks, you don't have the time to do it, you just leave a blank. And it's there for when you want to fill it in. And then I mentioned before domains. This object here in red is a domain, and that's basically saying this domain is called yes, no, very simple. It's just saying that we have, for these questions, like does the building have water or gas, the only possible answers that you can put in there are yes or no. There's no maybes. So that basically it's just things in there to be able to help you control your data. And that's it. So while you guys digest all that information, go have a cup of coffee, and we'll come back in about 15 minutes.